Innovation doesn't happen in isolation. At Zircuit, we believe the future is built by builders. That's why we're spotlighting exceptional builders everywhere. Those building on complementary ecosystems and advancing Web3 for everyone. Whether you're building on Zircuit, building alongside us, or building something entirely new, this is your community. Welcome to Builders Showcase. Let's build the future together. For today's builder session, excited to have Goldsky, officially come on board and essentially explore what you're building, what your solution is, and how it impacts the Zircuit ecosystem. So, I guess without further ado, Andrew, can you give a brief introduction about yourself, what you're doing with Goldsky, and how you're just like a little bit about yourself.
Yeah, absolutely. Let me go ahead and share my screen and I can dive into it. I've got a slide actually right on that. Although one sec, I think I might need to hop in and out for the permissions for my share screen. Give me 1 second.
Oh yeah, the Discord,
Yeah,
the Mac permissions, yeah.
Yeah.
No
Give me 30
worries.
seconds. I'll be right back.
Awesome. Yeah. So, by the way, this builder sessions, we want it to be a little bit more interactive. If at any point you have any questions, feel free to type them in the chat. We'll have them answered as soon as possible. Andrew's going to be giving like a short demo, and again, like he's the resident expert in all things indexing. So hopefully you'll get like a little bit of an insight on what indexing is and how it can be tied into what you guys are building. Okay, perfect. Okay, he's already in. Awesome.
Alrighty. Cool. You hear me okay still?
Yep, we hear you loud and clear. At least I do. Hopefully everyone
Sweet.
else does.
Awesome. Well, I'm going to go ahead and dive in. You know what? Let me make sure it's showing the right screen. Yeah, I think it's showing the wrong one. 1 sec. All right. So to kind of dive in, a little bit about me. So my name is Andrew. I am the customer success manager at Goldsky, and it's a fun role. Basically, what that means is my main priority is figuring out all the different ecosystems we work with. What are the main priorities of the builders on their chains, whether it's individual developers or dApps or teams, and sometimes even chains themselves. We'll use the, Goldsky for analytics or for creating incentives programs. So really my main goal is to work with the platforms and the chains and the ecosystems that leverage Goldsky and figure out how we can make it a better experience, both from a performance, usage analytics standpoint, as well as UI, UX, right? Just figuring out how to make things easier, whether that's doing workshops like this, talking to teams in Telegram, creating developer documentation, right? My goal really is to streamline everything. And it's a two-way street too, right? We get to learn about what the pain points are and kind of bring it back to the product team so that as we figure out what are the most important priorities, we can kind of build the product better, make it even faster, make it, easier. So it's a cool role. Probably my favorite part is the travel, planning to hit DevConnect next month. Very excited for that. All the events are fun. Seeing people in person is fun. So yeah, that's essentially what I do. Now, quick overview of what we're going to be talking about today is primarily what is indexing. Next, what are subgraphs and how to deploy them on Circuit. And briefly touching on Mirror, just so that you know what it is. It's not currently supported on Zircuit, but it is one of those things where if you're multi-chain and you're looking at, for example, mainnet or other layer twos, and you kind of have a multi-chain app or approach, Mirror can be something that is very helpful. So I'll just briefly touch on that just so that you guys are aware of what it is. But at a very high level, exactly, indexing is pretty much the way to really optimize getting on-chain data, right? So typically people will use RPCs, make their RPC calls. Indexing is a different way of doing that. Subgraphs, these are customized GraphQL endpoints where you basically choose the kind of data you want to look at, deploy the subgraph, and then you query it to get the data that you want. And then mirror is similar to subgraphs, although instead of pulling the data and querying it, you're basically taking whatever's on chain, putting it into a database in a more of a push fashion, so it's real-time streaming. And that's something like, putting it into Postgres, ClickHouse, S3, along those lines. But to kind of touch on, indexing a little more, just to give you context on why it's important. So if you're going to be looking at on-chain data directly, it's going to be pretty complicated block data. I mean, there's the transaction index, hash, block number, topics, right? There's just a whole lot of stuff that you look at that is really not clear and easy to digest. And on top of that, too, when you are doing these RPC calls, you get often limited as far as what you can do. They're not very efficient. Sometimes they're slow. A lot of the time you're going to get rate limited. And if you're going to be combining, multiple different queries, different smart contracts, if you're doing complex things, you're just really not going to have an optimized experience when you're doing RPC calls directly. So essentially, this is where subgraphing comes in. It really just optimizes the experience of reading on-chain data. So when you're a developer, some of the headaches you might get from RPCs are really abstracted away with indexing. So just to kind of compare, give you a side-by-side overview. So when it comes to querying, RPCs are just going to be more simple lookups, whereas indexing, these are data structures that are designed to be queried. So you can do really complex queries and get very specific about the information you want. And with that comes optimized performance, right? Because simple lookups, these are going to be more slow and just rate limited. Whereas when you've got a query optimized data structure, you can really quickly get exactly what you need, and it's going to be less resource intensive. So it's just much faster. And surprisingly, RPCs are actually way more effort to maintain and deploy than indexing. So it's both much more optimized and easier to do. So developer effort is, believe it or not, actually lower. Scalability, on the other hand, is significantly higher, right? When you start deploying a ton of RPC calls, that adds up. That's not really the most efficient. But with subgraphs, you can deploy hundreds if you really need to, and it can really be designed to optimize and scale with your app. So, other things like decoding and aggregations, a lot more automated and simple with indexing versus RPC calls. So overall, I mean, it's just one of those things where if you just have a basic requirement, like, you don't really have anything too complex, speed doesn't matter. You can do RPC calls, they're basic and they work totally fine. But as soon as you do anything remotely complex or your app starts to scale or speed is important, you want a snappy UI, you're going to have to do indexing, and subgraphs are going to be a good way to do that. So what exactly is a subgraph? You might be sitting there wondering. So basically, there's an indexer that scrapes the network, and what it does is it efficiently and then continuously extracts this data. So you can almost think of it as like a magnifying glass that is looking on chain and getting you exactly what you need. So similarly to how, if you want to find some kind of website, you're not going to go through every single website on the internet and then find the link you want. You're going to Google a keyword and it's going to be surfaced to you, right? It just scrapes the internet, gives you the keyword, or gives you the website you want, something we're all very familiar with. So an indexer is, it's different, but an analogy would be that it's like the Google for on-chain data, where you're efficiently scraping for what you want and then being able to, continuously extract that in just a much more efficient way. So not only does it extract that efficiently as the indexer, but it also transforms this data. So what it does is it takes it and it structures it into this data structure that is just organized, and it has what are called entities. And we'll go over what those are and what you can do with that. But basically, these entities are a more readable format that you can understand on-chain events with. So it just really makes it a more digestible form of using the data. And then it's stored off-chain too, so that's how it's really optimized, right? It's going to be data that is in an off-chain database that is optimized for queries. And then you query it by just calling the GraphQL API endpoint. And in addition to being able to query it, there's a few features we'll touch on, like tags, webhooks, versioning, that just really streamline the experience so that, when it comes to subgraphs, the whole experience is just smooth, fast, and easy. And I'm going to give you a quick demo just to show you how quick and easy it is. So if you haven't yet, go to app.goldsky.com, sign up for an account. Super easy to do and quick if you want to follow along. But pretty much deploying a subgraph is as simple as clicking new subgraph and filling in the details here. So we'll go one by one. So subgraph name, I'm just going to call this Zircuit demo. This is the first version of it, so we're going to go 1.0.0. And contract address. So I'm going to go to the Zircuit Explorer, and I was just looking at top tokens, and ZRC is the number one. So I'm going to use that as an example because it's an easy one. So basically, you take the contract address right over here, copy and paste that bad boy. We're going to go to Zircuit mainnet. Now for start block, if you wanted to get historical data of the contract, you can enter like the block where it was created. But that is going to give you a lot of data because it's going to be the historical context of that entire smart contract. So for this example, I'm just going to look at one of the latest blocks, copy that guy, and we'll do like a 5 here, just so it's, a few thousand back so that you can see just an example of more recent data. And last but not least is the contract ABI. So most contracts in the contract tab, they're going to have an ABI section. If it's a smaller contract, maybe they don't have that attached to it. If you literally just search ERC20 ABI on Google, it'll come up with a pretty standard ABI, which you can just use. But here we have it, so it's easy access. We'll copy and paste that. And that's it. That's really all you need. You can deploy it. Now with Goldsky, we do have a CLI that you can use in the terminal. And that's going to be, the more coding version. If you're more technical, you might want to do that. A lot more flexibility of how you can get as far as customizability and, advanced queries, but really simple stuff. It's super fast to just deploy here and it's easy. So you deploy it and it takes just a few minutes to basically start loading it up. But whenever you do deploy a subgraph, we'll just give it a second there. I'll reload the page. Oh, maybe it didn't work. Here, I'll do it again real quick. The demos always don't work. That's just the law.
Yeah, the
But
curse of the
it's
demo.
super fast. Yeah, it's super fast to do it. Like I'll show you right here in like 30 seconds or less. I'll just get it done. So we go back here, get the contract ABI, boom. And then transaction. Oh man, I don't know what's going on there. Maybe it's something with my browser. I have a ton of tabs open. Sometimes that could be related to that. All right, we'll give this a shot. If for some reason it doesn't work, I can show you an existing subgraph just for reference so you can see, what the different metrics are that you can expect and, how it typically works when you are querying. But one more shot just to see if it'll work. There we go. So once it's deployed, there's going to be a metrics page like this, where it's essentially going to be your home base to get insights into, what kind of information you're seeing in the subgraph. So as it's indexing, it'll kind of, have like a progress bar as it goes through. But to really understand what you're seeing here, new entities are going to be basically like the type of on-chain events that you're tracking and indexing. So when you scroll down, you can expand on entities and it's going to show you the types of entities that you can see. So an example would be an unlock, transfer, approval, and these are basically mapped out in the ABI. So that's why it's important to have a contract ABI. You're basically copy and pasting essentially a blueprint, and it's like a set of instructions for how to map on-chain activity into this more readable, digestible fashion. So that's basically what entities are. And as you can see, this is already live. So as you are querying your GraphQL endpoint, it's going to show up here as more API requests pop up, just so you can see how you're using it. But each subgraph, once it's deployed, gets its own custom link right here. So when you click it, this is what you can expect to see. And Typically, you can add something like transfers if you just want to see something very basic to see, the results of the most recent transfers, right? This is just the first 8 ascending order direction. You can customize the kind of information that you want. What's really cool is there's this explorer where it basically maps out everything that the ABI allows you to look into. And so you can kind of click and create, the different queries that you want based on what you need and what that contract has available. But really, really cool. It's just a simple API endpoint. You query it. This is something you would plug into your app. And I think something that is really helpful to know, this is a feature that not everybody is aware of and not everyone always uses, is subgraph tags. Now, if you take a look here in the website URL, you'll see over here is version 1.0.0, right? So let's assume you create an app and there's 5 different parts of your front end, maybe 5 different parts of your back end. All are calling this endpoint. And then you realize you want to modify the subgraph, customize the kind of data you're getting. So you make version 2. But now you got to go back into your app and update the URL because the URL has 1.0, but then you now have version 2. Luckily, if you have tags, you don't actually have to do that because what you can do here is make a tag like prod, for example, where it creates a brand new GraphQL endpoint that has now prod versus the version number. So you can paste that anywhere in your app, 10 times, 20 times. And then as you're making the version updates, you can then reference, the latest version by using the tag, and it just points to that. So that saves a ton of time. It's a really small thing, but it's super annoying if you run into it and don't realize that there are tags. So it's like a little detail that is a huge time saver. Now, there's also webhooks, which are a really great feature. Let's say you want to trigger some kind of action either in your front end or in your back end. Maybe you've got some kind of dashboard, some analytics you're doing. You can create a webhook to automatically trigger events based on on-chain events. So that can mean something like, notifications or unlocking access based on certain liquidity or certain NFT zone, something like that, right? So webhooks are a very powerful feature and you can attach them to any subgraph. So basically, at a high level, subgraphs are a really important way to get on-chain data, pull that with an API endpoint, and then you have this page over here that just kind of gives you insights into what your subgraph is doing. You get some logs. You have insights into the amount of entities that you're indexing, and yeah, it's a very powerful tool. So going back to the demo, now I'm not going to touch too much on what Mirror is, but I will just give a little overview. So essentially, Mirror you can think of is like the next evolution of indexing. When it comes to subgraphs, they are very powerful, but they do have some limitations when you start scaling to the apps, the size of Polymarket, for example, or if you're going to be combining information from multiple chains or from off chains, or if you want to do fuzzy search or, real-time data. So when it really counts with scalability, and especially as transaction speeds get way, way higher, subgraphs are going to fall short and they'll still operate, but they might not be as efficient as people might want if they're used to those Web 2 speeds, right? So this is where Mirror comes in, where essentially it's a different way of storing this data. So rather than anytime you need the data, you're querying an endpoint, instead, you're going to be querying directly from a database. So essentially, when it comes to latency, you're literally just limited to the speed of your database, which is incredibly fast. So once the data is in the database, it's pretty much almost near instant. And you can create a pipeline, a Mirror pipeline with various different sources. So you can even make a subgraph that you deployed a source. You can choose a specific chain. We have all these data sets that are pre-indexed that you can just kind of plug in like ERC20 transfers, raw logs, traces, and you can take that, push it directly into your database, and then query from within your database. And that's extremely useful if, let's say, for example, you want to combine Zircuit data with Ethereum mainnet data with some kind of off-chain data sources you have. You put it all in one database, multiple tables, one table, however you want to do it, and then you query that table directly. And that's where Mirror becomes really powerful because it just kind of unlocks what you can do with your data and you're owning it too. So there's more flexibility there. So in essence, at a high level, Mirror is real-time streaming to a database, rather than an endpoint that you're querying. you're pushing the data into your own data stores and you're querying from there. So that gives you full control of that storage, of what you do with it. You have it forever. It's going to be yours from now on. You can combine multi-chain and off-chain, really designed for scalability. And you can either use historical data or stream at edge, which is just anything current moving forward. And it's really easy to deploy a pipeline too. I'll show you. It's really not as complicated as it sounds. And when it comes to deploying a subgraph, it's a very similar flow, right? So deploying a pipeline, you just hit new pipeline, you get sent to what we call flow. This is like our little canvas where you can create these. And it's a simple drag and drop, right? So for this, I'll just use Ethereum as an example. You just basically pick your data source. We'll go ERC20 transfers. Maybe we'll want it to be current. So it's going to be at edge, everything moving forward. Because keep in mind, if you go from the beginning, Ethereum is a big chain. You're going to have a lot of data, and that might cost you a decent amount. Although even indexing an entire chain like Ethereum is pretty cost efficient when it comes to mirror. Pipelines are much cheaper than subgraphs, so very efficient. But basically, you choose your data source, you choose how you want to customize it. So similarly to how in a subgraph, you have the endpoint and then you can query it to get your data. So you can query within a pipeline as well, so that whatever's being put into your data store is just the subset of data that you want. So here you can write a query, you can, isolate a specific address or a specific set of, contract events that you want to look at. And then last but not least, you choose your sink. And the sink is going to be your database. So whether that's something in ClickHouse or hosted Postgres, which is a solution where we host it on our end and you can leverage that. You have a lot of options, and it really just depends on how you want to use that data. But once the subgraph is once the pipeline is deployed, it's just going to be real-time streaming, live, continuous feed into your database. And it's a very, very powerful tool. So to kind of sum it up, you've got subgraphs for pulling and querying data. You get that API endpoint, and you have those pages to kind of monitor that. And then mirror is going to be data streaming pipelines, where you are putting that data into a database and querying within there. But essentially, the main reason for any of this is you want to efficiently create data structures so that you can find the data you need quickly and not have to worry about maintaining any kind of infrastructure. So generally, if you guys do have questions, you can reach out to me. You can reach out to our support team. And I'm going to pause there if there's any Q&A. And I know that we've got a few questions lined up as well. So I'll take a pause there. I know I went through a lot.
Yeah, absolutely. Thank you so much for the overview and essentially like the description of what Goldsky does, and a live demo as well. Like you got it to work, and yeah, I guess yeah. My first question in all of this. So when you're building Goldsky, when you're taking this data that's I guess indexed in this way, like how does Goldsky differ from other indexing providers that might exist, and can you explain like what maybe like the key features that Goldsky would provide over others?
Yeah, for sure. So I think the key things to highlight really are performance and reliability. If you go on our status.goldsky.com page, it's kind of wild. It's something like 99 or 99.9% uptime. So when it comes to reliability, that's definitely something that we put a lot of effort into. But there's a lot of enhancements too. So there's like a rewritten RPC layer, storage optimizations, there's auto scaling, multi-RPC failover. So really it just comes down to speed too. We deliver really fast queries when it comes to other competitions. But yeah, I mean, we're backwards compatible, right? So if you're on the graph and you even want to just test it out, you can do like the free tier. We have a really simple like one-line migration you can use, where you just migrate your existing subgraph directly to Goldsky from the graph. And it's really easy to just kind of port it over and test it out and play around with it. But yeah, I mean, in addition to just, simple speed, reliability, I think webhooks, versioning, and tagging are really key here, because that just optimizes the experience. and, makes things easier, just like little tiny things that save time and it adds up. And then of course Mirror too is a really powerful tool. It's a very different approach than Subgraphs, and I think for sure stands out as a solution. Especially it works for non-EVM too, right? Because Subgraphs are strictly EVM, just based on how they're structured. And Mirror allows for non-EVM as well. So we support things like Solana, Sui, even Bitcoin. And so Mirror is a really cool use case where you get that non-EVM indexing.
Awesome. And actually, on that point, can you explain how the data for non-EVM chains can get indexed? You said that subgraphs are specifically tailored towards EVM chains. Why is that? I thought all blockchains sort of have their own like type of transactions, type of data, but like all blockchains contain data. I guess why are subgraphs tailored more towards EVM versus non-EVM?
Yeah, that's a good question. I don't know all the exact technical details, but my understanding is basically there's like these ETH calls or ETH get. There's like these certain methods that are just built into EVM that are required to even use a subgraph, and that's just kind of how subgraphs were built. I think initially they were built primarily for Ethereum, and then all the EVM L2s came out, and it kind of by EVM extension worked on those as well. But other chains that don't have like ETH call, for example, if it's not even EVM, then there is no way to use a subgraph which is designed to use those methods. So my understanding is the indexing is different because the way that the RPCs are called and the way that the data is stored, there's just different methods, and it's just another way of gathering the data. Because, for example, we still have to use RPCs at Goldsky, right? Like we have various providers and we have fallbacks, and so we essentially still have to call the data. So I think it's part of how the data is called that different chains do it differently.
Gotcha. So every chain does it differently, and as a result, you need different, let's say, like data structures or ways to essentially get that data and format it in that way. Very cool.
Yeah. And something that's cool too is like, for example, like we support Solana. So once we figured that out, we now also support Fogo, which is an SVM. So like once we have a certain method, like the SVM kind of figured out, then new chains of that similar method work, right? So like, for example, there's Move. So we have IOTA Move and then Sui. They're both a similar kind of language. So once we create one, we can reiterate and just kind of make it for other chains that follow some similar patterns.
Cool. Awesome. Like tons of replication and support for many different types of ecosystems. So essentially Goldsky can provide like many different types of support, not just for EVM, but also like multi-chain expansion, multi-VM expansion even. So I guess you briefly touched on this. You said like the ability to deploy your existing subgraphs to Goldsky, and essentially like the portability of these different types of subgraphs that you might create locally. So how do developers need to like modify anything their existing schema in order to deploy to Goldsky? And like, I guess is there maybe a more custom way to essentially use Goldsky to build these different types of subgraphs?
Yeah. So generally, it's actually plug and play, right? Existing subgraph schemas and mappings will typically work, and then you can port them over, and then later on add on custom indexes and different queries. But yeah, I mean, as far as when it comes to onboarding, you can just deploy your existing subgraphs with pretty minimal changes. We're backwards compatible with GraphNode specs, so you can just keep your same schema, keep your same mappings, and then just benefit from our infra, which is going to have the caching, auto scaling tags, webhooks, right? So it's really easy to port over, and you don't even have to make any drastic changes at all.
Awesome. Sorry, just checking if there's any questions from the audience as well, like right in between that we have. So in terms of this portability and support. So very good to hear that everything is primarily plug and play. Like I think in order to take in that developers from different ecosystems from different solutions, I think like very imperative to have it. So that's another reason why we're Zircuit is also EVM equivalent, and so like we're coming in and trying to be as close to what people are, what the developments of Ethereum are, and trying to match that towards that implementation. So I know like recently we switched over to a ZK VM, which allows us to better adapt to the EVM. So the Fusaka is coming out, and having that upgrade, we want to be live with whatever the developments are. So really cool to see how Subgraphs or Subgraph services like Goldsky are adopting that similar approach for this type of development. But yeah,
and what
sorry.
thoughts on ZK? I think that it's a really cool technology, and especially recently too. I mean, everyone's talking about Zcash. It's been all over the timeline. I think that ZK in general, like this way of privacy enabling tech, it's very much something that's top of mind for people. Curious, just what are your thoughts on that in general and the direction it's going?
Oh yeah, so ZK has had a lot of developments. So I think if you go to ETH proofs even, so the proving time for a block is very, very close to being real time. I think like SP1 is currently winning on that front with like a minute and 30 seconds to prove a block. I think depending on like the type of block and the amount of data, with that, like real time proving can be achieved. And then from that, security in the sense of like privacy. Right now, like I know like Zcash, for example, is like really big and in crypto Twitter, and so you have like, and then privacy preserving protocols using ZK as well, that are also being essentially like tied into this privacy movement. So I know like Tornado Cash, Railgun. So like these privacy pool are also getting like a new light. And I think the importance of ZK with different types of products, not just with finalization, not just with privacy, but maybe even with the ability to pull external data without having to like the applicability of that outside of the blockchain space. So very, very, very cool to see how all of them can there's many different use cases that ZK can provide, and we're getting even closer to being able to do these real-time ZK operations at a lower cost than what it was like a few years ago. So we're gonna I think see a lot more of that applicability being present as the years go by. And of course, Zircuit is ZK, using ZK technology from the start. So like we're catching in on all of those improvements and all of those essentially, like, although it's not built for privacy, we're going towards more of the direction of how do we use ZK in a way that makes sense for the finalization aspects, and then maybe integrating this within more aspects as this technology evolves into something where we're ZK native. We can maybe adopt other ZK native solutions as well.
Yeah, ZK it's a powerful tech, and I really think it's gonna just only grow in popularity and prominence over the next few years, because as the really large banks, institutions, large enterprises, as they all start going on chain, because everyone's talking about stable coins and real world assets, tokenization, right? It's at this point, it's like it's not an if, it's a when, right? Everything's going on chain, probably stocks, probably payments, remittances, even paychecks. Like everything is like, it's just ACH is just slow and outdated, takes time, right? It's like everything's going on chain. But as more goes on chain, we don't necessarily want more to be visible too, right? Like if a bank has all their operations on chain, they're not going to just want to show the entire world how much everybody has in their personal checking account or where they're moving their money, right? So banks for sure are going to want to have privacy, and same with the institutions that are, managing their treasuries or their assets or, pretty much anything. It's like on-chain is definitely the superior tech, but that transparency is both good and bad, and it's sometimes for the more private sectors not ideal. So ZK is just a very, very important technology that, it's pretty clear is going to only become more prominent.
Yeah, exactly. Well said. Now, for relating this, back to maybe like indexing, ZK indexing, and everything, like maybe let's tie in AI as well. I don't know. We're gonna need more buzzwords. So with the new facets of AI, so one narrative that is being adopted is the provability of or the verifiability of data sources that AI is essentially taking in. I know indexing, for example, is a way to basically break down or collect data and organize it in a way where it's easily accessible by things like websites, but I think also AI agents. So in a way where I can maybe collect the historical yield of the different types of DeFi pools that are present within various different types of ecosystems. And as a result, knowing the historical yield, I can maybe choose the best strategy that has the largest returns over a big enough period of time. So I guess outside of that aspect, or maybe even within that aspect, maybe that's like one of the prominent ones. How do you see the AI or machine learning and indexing working together? Maybe if you could tie in ZK there, but obviously that might be a lot with with that question.
Yeah, no, for sure. I mean, AI and agents are a really key part of what we're focusing our energy towards moving forward. We believe that autonomous commerce is going to be a very, very big part of what's happening online. And we might even see in the future, the majority of on-chain transactions being done by AI agents, right? So basically, you might just talk to your wallet and it would just do things for you, right? We don't know where it's going. But basically, at Goldsky, we are trying to create a framework where agents can easily access the data too, right? So we're trying to streamline it so that not just can developers can use data, but easily plug into agents this on-chain activity so that agents can make more informed decisions, right? Because agents, LLMs, they'll want to be able to have as much access to accurate data as possible. So this is where something like Subgraphs and Mirror are actually critical, where these agents may need that real-time data, right? So something like Mirror, where you're real-time streaming anything happening on chain as it happens immediately, essentially, would be really important for an agent to have access to if it's going to be making decisions on the spot and analyzing risk and figuring out what are the best methods of like next steps. Then having real-time data is even more important for agents to basically make the most informed decisions. And another route that we're looking into exploring too is not just reading on-chain data, but then also writing on-chain data too, performing certain actions. Maybe you're going to have an agent read a certain activity on one chain and then perform another action on another chain, so cross-chain applications, writing on-chain access, right? So there's going to be a lot of ways where agents are going to not just read on-chain data, but then actually perform on-chain actions. And at Goldsky, we're trying to create a flow where it can all be this simplified, unified flow, right? Where an agent can both use us to get the data and then perform actions all in one seamless flow. So it's for sure top of mind for us. And ZK can come into the equation too, because let's say an agent's reading on-chain data, then when it performs the action, that's the part where we probably lean more on ZK, where you want to maybe maintain the privacy when it's actually doing things, right? So really cool future coming, and I think it's going to be here sooner than people expect, and it's all going to come together.
Yeah. I actually, stemming from that real-time nature of things, like one of the things that Zircuit has, and the key differentiators for Zircuit specifically, is the SLS. So it's a sequencer level security. Essentially, it's real time AI detection for the different types of transactions that might be malicious. So if there's like a malicious like phishing transaction, or if a malicious, for example, function were called that would drain your wallet, that essentially is being detected right now by our SLS mechanism, which is able to catch those results very, very early. So very good point to point out how these AI systems and services need access to real-time data. And potentially Goldsky is there as maybe like an additional provider for this these services. Maybe there's like a like in the future. I'm not the direct person that designs these structures, but maybe like in the future there's a way to do these redundancy to be able to if one provider isn't able to essentially be real time enough, then there's the ability to do these redundancy in a way similar to how just leveraging one ZK VM gives you security, but if you use multiple ZK VMs, you get more security through this type of redundancy, and as a result, you have better security guarantees for the services that you're providing. Infrastructure, very important as an overview.
Yeah, I'd say that's pretty spot on.
And I guess when you're looking at the future of Goldsky, you're looking at providing different services like primarily indexing. But do you see new features or capabilities on Goldsky's roadmap? If so, like could you share, maybe like give a bit of alpha for what's in mind?
Yeah, for sure. So that element of writing on-chain data, we made recently what's called Goldsky Compose. If you search for Compose on X, it should come up. It's essentially that, right? It's writing on-chain data. So we actually recently partnered with Polymarket, and we're powering part of their operations using that. So it's a pretty cool segue into agentic commerce, where the agents are going to be not just reading but actually using something like Compose to take actions on chain and to actually write data. So that's a very, very big thing that I think is going to be more prominent. We're seeing a lot of other companies starting to do this kind of thing too. It's definitely a need in the industry, and I think it's only going to grow. So that's for sure the biggest alpha I think I can share today, is that going from just reading on chain to now writing on chain is a really, really big next step, I think, for the industry.
Awesome! Wow, Polymarket as a client, so that's very big, and definitely good to see that AI agent adoption within that feature. So yeah, sure. We'll be good to do a bit of research and see how potentially this can be leveraged within other ecosystems like Zircuit, because we also have like our own AI agent angle, more so towards DeFi based operations, but we can see the prediction markets or different things also being created. So maybe we can talk later about that as well. And I guess sorry.
No, I was just saying, yeah, for sure.
Awesome. So I guess like one final question before we wrap up. When looking at the different teams that are building different projects, different partners that you have, like you have a wide variety of different builders, from early stage to late stage. You mentioned Polymarket is one of those. I guess from this wide area, what advice would you give to teams building data intensive blockchain applications? And then maybe how would they best leverage Goldsky for that, if you have like that direction? If you don't worry about it.
Yeah, I mean, honestly, I would just say getting a solid understanding of the data needs you have, right? Figuring out exactly what's the most important for you to track. Understanding what on-chain events are the most critical for, like it's basically like finding the most impactful levers. Like, how like in physics, if there's like a lever and there's a special point, like you can lift a lot by having a shorter end, something like that, right? So just finding those levers to have as much leverage as possible by the most efficient way. So basically just being really optimized and granular about which data is most important to you, and then figuring out with our team how you can get the most efficient about getting that data, right? So rather than indexing an entire chain for your app, maybe you just want to look at a specific contract or a specific set of entities within an ABI, not even the whole thing, right? So just really understanding how you can optimize as much as possible to be cost effective, to be fast and reliable, and working to basically get as optimized as possible. I think that's a good thing. So kind of knowing what to look for helps you find it faster.
Awesome, and definitely, would definitely suggest, talking to Andrew if you have any questions related to that. Maybe, that support angle, would be better. He can maybe take a look and tell you how to better optimize different things as well. I definitely would yeah, because I maybe we'll run into some using Gold Sky for future projects. Maybe would run into some ways to optimize indexing in a way where it doesn't run up the bill too much. So awesome. Thank you so much, Andrew, for coming in on this builder session. I guess, do you have any final thoughts, last perspectives or anything to people listening in?
Yeah, I mean, I just to kind of wrap things up, I would just say go check out app.goldsky.com, give it a shot. I think you'll find it's easier and more simple than you would expect to deploy this stuff, and you'll get a lot of really cool data really quickly. So take a look at our docs as well, docs.goldsky.com. There's a lot of guides there, video walkthroughs. So, you should have a lot of resources to help you get started. And, it doesn't take much to get started too. It's really simple. So definitely just give it a shot. I think that doing is often the best way to learn. So go for it and reach out to our team if you have any questions.
Awesome. And yeah, I guess we can end it